Alright, so let's integrate arctan root x dx. So for this, the first thing I kind of want to do is, since I see a root x over here, it kind of comes to my senses that I should do a t substitution. Not really a u substitution, because I feel like I'll get confused as I sense that this problem will have an integration by parts element as we move along. So I'm going to do a t substitution where I'm going to be setting my t equal to root x. Then therefore my t squared would be equal to x by itself. And finally, to replace dx, I know that 2t dt would basically be equal to dx. So now I can replace my stuff inside here. So this is going to be equal to the integral of arctan tan t 2t dt. So to not get confused, I replaced this over here, right, with t, and then this dx gets replaced with 2t dt. Now you may be wondering, how did, it become t instead of t squared? As what happened? So since we have a root x, the square cancels out the root, and so we have arctan t 2t dt. Alright, so our next step here is we can kind of see that there is a integration by parts element happening. So let me write down the integration by parts formula, which is, so put in green, and I'll put it over here on the right hand side. So u dv is equal to uv subtract the integral of v du. So there's some things that we need to find, like u, dv, du, and v. So let's do that. I'm going to use the color red to represent my findings. And remember Light, where L stands for log, I stands for inverse, A stands for algebraic, T stands for trig, E stands for exponential. So from this we can figure out what our u sub should be. So here we have an inverse, right? Arctan is an inverse trig function. So therefore our u should basically be equal to arctan t. Then our du, right, should be equal to 1 over 1 plus t squared, right, dt, which is just the derivative of arctan t. Okay, now let's get our v. So to find our v, we first need to get our dv. Our dv is basically going to come from whatever's left over, inclusivizing the dt as well. So our dv is going to be equal to 2t dt. And from this we can figure out that our v is going to be equal to t squared. Alright. So now let's continue on with the problem. So now let's just write out everything in this formula. So we write this out in the color black. So our integral of arctan t is going to be equal, arctan t 2t dt is going to be equal to arctan t times t squared subtract t squared times 1 over 1 plus t squared. Now you'd be asking, where did I get these values from? I just looked at this formula over here, just sewed my values in, right? So u dv would just be our integral that we have, right? As u dv would basically be arctan t t squared. UdV would actually be arctan t 2t dt. My bad about that. And uv would basically be arctan t subtract the integral of v t squared du, which is 1 over 1 plus t squared dt. Forgot to put my dt here. Okay, now let's solve this. All we have to do is take the integral of this individually. Sometimes we might have to go in loops, but we'll see if we have to go in loops for this one. So I'm going to put a star here. So I can simplify this into one singular expression and manipulate it in order to do this. So it's going to be t squared over 1 plus t squared. Correct? Now, if we do a manipulation trick, we can see that this is basically equivalent to this expression over here, where our 1 is equal to 1 plus t squared over 1 plus t squared. Correct? So now if I was going to simplify this even further, I would get 1 minus 1 over 1 plus t squared. So in essential, this over here and this, they're equivalent. So I can just replace it. The benefit of that is that I can integrate these separately and I would get some very good, easy to work with values. Alright, so let's do that. So our integral in blue, let's do that. T squared over 1 plus t squared is going to be equal to the integral of 1 minus 1 over 1 plus t squared. And I think I forgot my dt here. I'll just add my dt here as well. Very essential that you keep it there. It's part of the format. So now when you do the integral of this, integral of 1 would give you t. So this is basically equal to t. And then from here, you would see something amazing happen. You would basically get minus arctan t, right? So this basically is equal to this when you take the integral of that. I'm not going to work with my plus c right now. We'll just add it at the end. All right. So let's go back here and substitute what we know. So this is going to be equal to arctan t times t squared. Now this negative symbol, I'm just going to distribute it alongside what I know here. So it's going to be minus, right? It's going to be minus t, and then this is going to be plus, since I had a negative sign here. It's going to become plus arctan t plus c. So now we've got our foundation to finishing our problem. Now all we have to do is substitute back whatever our t sub was, which is root of x. So I'm just going to bring this t squared up here just because it looks nicer. So now it's going to be, remember, if I have root x squared, it just becomes x. So we get x times arctan of root x, right? We have a tan t, so root x, subtract t squared, which is going to give us a value of actually, you can see that I kind of made a mistake here. I just noticed it right now. So if I have remember, I did not get t squared. Rather, I actually got a value of t. So let's get rid of that. So this should be root x plus arctan root x plus c. So this should actually be your final answer. And that is how you solve this integral. Have a good day.